Hello, everyone. Thanks for joining Interface today. We're very excited that you can join in our next ForceLeaders webinar, Advancements in Instrumentation. We've covered instrumentation in the past. Today, our experts in solutions are Keith Skidmore and Ken Bishop. They have a lot of experience in applying instrumentation solutions to the devices that we offer. And they're going to go and take a deeper dive into some of the advancements, trends, do's and don'ts, and some new technologies that I think you'll find of interest. So really excited to have Keith and Ken share their know-how here. Again, thanks for joining Interface. We'll have a recording of this event that we'll provide you at the conclusion, as well as we'll offer you an opportunity to ask questions by using the chat feature. So to kick things off here, the topics that we're going to cover today are types of advanced instrumentation, selection criteria. We're going to go over the digital versus analog conversation, wireless and Bluetooth, and then we're going to talk about some new types of instrumentation that Interface offers, as well as trends, applications, and then get to those questions. So ready to kick things off here? Keith, Ken?
Hi there, this is Keith Skidmore. Let's go. Advancements in instrumentation. So what's changed over the last 5 years? What we've seen is more and more people adding sensors into things that didn't used to have sensors, which is pretty interesting. You think of someday your refrigerator may be able to tell you if you need to buy more milk, those kinds of applications. The IoT into test and measurement, where lots of things are communicating with each other, lots of more data being broadcast around. Smart factories, vehicles, tools, you name it. Lots of things are having built-in data logging or data transmission. We're able to do more customization and programmability. A lot of people are asking for kind of, different things, not just a plain old signal output, but they want to do certain things that we've been able to program in. So a lot of people doing more with more data analysis, monitoring things like on an assembly line, things that used to not be monitored are now being monitored. They don't know why necessarily, but you're going to collect this big data set, and then there's a problem down the road. You can go back and analyze it and see where the fault came from. More digital interfaces too. Interface has been in the analog world forever. Most sensors have analog outputs inherently. Those can get signal conditioned up into digital signals, then that can be interfaced into field buses and into customers' data systems. And so we've got more and more interest in people skipping analog and going straight into a digital interface. Next slide, please. So types of instrumentation, we talk about signal conditioners. These take a low level millivolt per volt signal from a sensor and condition it and amplify it either to an amplified output or digitize it to a digital signal, or maybe both. Data acquisition systems take sensor data and display and log it and do analysis and various things usually running on a PC. Indicators display data. Sometimes they'll have digital interfaces, they'll have analog outputs, so they can sit in the middle sometimes if you want a local display, but you also want some other functionality. Wireless and Bluetooth, we'll be talking about that. We're getting a lot of interest, more and more interest every day on wireless systems. People like to break the cable connection. USB interface modules. In many cases, what people used to do with like a standalone display is now able to be done on a PC, and everybody's got a PC. Laptops and standalone little computers are frequently widely available. And so why stick with a display when you can have a PC as a display, and they can do all kinds of great things on the PC with the data. Portable systems, either battery powered or suitcase type systems, rechargeable, you name it. And then we're doing a lot more with TEDs. A lot of our instruments are TEDs ready these days. And then we also have the ability to have TED chips with, say, custom programming on them for customers who wants to, do something proprietary. We can do that as well. So moving on. So talk about digital outputs and amplifiers. There's a lot of different digital protocols, Ethernet, TCP, IP, which is just your normal PC Ethernet type connection, Ethernet IP, which is totally different and not to be confused. Profibus, Modbus, Profinet, CAN, EtherCAT, you name it. I2 squared, SSI. There's lots of different protocols that people are asking for, and say 5-10 years ago, nobody was asking for this stuff, or it was a lot less prevalent, put it that way. Better software too, just the ability to kind of do more with the software, easier configuration, ability to do calculations in the software and actively, calculate things on the fly. Doing a lot of special packaging, amplifiers, somebody wants multiple channels and things, we can package them together. Somebody wants custom cables and custom enclosures and things, we're doing a lot of that. Doing more with TEDs, like I mentioned, there are templates that allow linearization or even polynomial fits of the data. And then, of course, really, if you want to do a proprietary system, anything you want on a TED chip can be read in along with the sensor connection and used to set up software that customers written themselves. So next slide. Digital amplifiers, talking about that a little bit. They can have analog outputs, but what they do is they digitize the signal coming from the sensor. And then once it's digital, you can do lots of different things that aren't possible when it's straight analog. You can have set points, advanced filtering, TEDs. You have I/O, where you can have a digital input to the amp and it can, do something upon that input. Nice thing about that is, you can write software then that has sort of a communication back and forth with the amplifier. Sometimes they're analog, so it's analog to digital, then digital back to analog. There's an advantage though, when you have digital, you can just keep it digital once it's digitized, and then that's one of these buses we're talking about, Ethernet or USB or whatever. But once it's converted, there are no more errors really. As long as it's a digital value, say 100 pounds, it's going to stay that all the way through the chain. Whereas if you're converting to analog and digitizing and back and forth, and some systems will have multiple A to D and D to A conversions. And every time you do that, there are extra errors added. So digital can keep it nice all the way through from the sensor. Next slide, please. Talked about digital amplifiers with analog outputs. One of the neat things, some of our amplifiers have a wide range of digital inputs and outputs, and our software that comes with them can make use of those as threshold set points or triggers and things, but also they're available. And we have DLL libraries and things that come with these items where the customer is writing your own software. You've got all these digital inputs and outputs that you can actually monitor the state of and have your software do something. So something completely special that, the standard software wouldn't do, you could program that. Say there's a machine that's cycling and it'll hit a switch every time it backs up and you want to start taking data, easily can be done monitoring digital inputs and outputs. Also, higher sample rates these days. One of the limitations of digital amplifiers in the past has been they've been relatively slow, is that the A to D is either slow, or if it's fast, it's real noisy. So we've gotten better and better. We can have high sampling rates and also good signal to noise ratio and low noise. Next slide, please. TEDs, we talked about that. A lot of our instruments support TEDs now. TEDs can be very nice if you want to deploy something into the field and you don't want somebody to be able to mess it up, right? So the instrument self-scales for the TED chip. The end user has to go to great lengths to screw it up. Whereas if, they're able to just press buttons and change things, you never know the status of it. So that's real nice. Also, if you have a sensor failure, you pop a new sensor in, TEDS identifies it to the system. It's up and ready to go without any intervention. I mentioned earlier, linearization and certain things are possible. And again, we can put chips on the load cells and customer can program them themselves with anything they want on them, IDs or, complicated commands even that they can read into their system and act on certain sensors being connected. So next slide, please. And handing it over to Ken.
Thank you, Keith. Here we're showing a Venn diagram of the different instruments that we have and how they kind of overlap with each other. As you can see, there's indicators only and signal conditioners. There's PC interface modules. Some of the indicators actually have signal conditioners built in. And so, we've recognized as a company that this can be a little bit overwhelming. And so maybe a tool that we should put together could help you. So next slide. So we're in the midst of putting this app together for the website. And basically what's going to happen is you're going to be able to go in and say, okay, I want an indicator or a signal conditioner, a PC interface module, or high-speed data acquisition. And then you could maybe select, oh, I need high speed or high internal resolution, multi-channel, maybe battery power. And then maybe you need some software. Maybe you're going to do some logging and graphing, or maybe you need TEDs like Keith explained, or some other kind of accessories, or even enclosures. We'll have this available on our website within probably 2 to 3 weeks. And you'll just go there, select from the list of drop downs, and it'll give you a list of instrumentation that'll match the criteria you're looking for. So obviously this, along with, of course, the great support you get from our application engineering team, you'll be steered to the exact instrument that'll fit your application best. Next slide.
All right, do a quick recap of digital versus analog options. And so basically, why would you select digital or analog? Digital, is there an existing network you need to connect to? Or I guess that goes for analog too. If you have analog inputs, maybe you need an analog amplifier. If you have digital input, well, what is it? You know, what protocols is it using? What, how do you do the connection? Again, it's an existing DAC device. It'll have established protocols. What is your budget? You know, if you want to go digital, but you have to buy all new hardware, that can break the bank. Or maybe it's something you want to do because it's important to your system, but you want to kind of configure everything from the beginning to make sure everything works together. So you want to, you know, tackle it as a system versus just buying individual components and hoping they work together. One good question is, how many sensors are you connecting? Digital starts to have some advantages when you have lots of sensors. Analog, you have to have a different analog input channel for each sensor, where digital sensors, you can bust them together and have one communication line, multiple sensors. Next slide, please. Again, why digital? It can be lower cost, especially when channel counts go up, because you may have to add a lot of expensive hardware to add your analog channel count, whereas digital channel count can go up quite inexpensively. Can work across existing networks. It's scalable without causing interruptions. What that means is you don't necessarily need to add equipment. If you want to add extra channels, you can just plug them into the bus. So you can daisy chain things together. Even something simple like RS-45, you can have, you know, 20 sensors, have them all chained together, so you just have one line running out instead of 20. Built-in error detection. Some of the systems, especially with multiple sensors, say you had under a tank or something, if one of those sensors goes bad, how do you know it? Well, digital can tell you. There can be certain error flags that come up. You can even maybe react and say, okay, it's not as accurate, but we know one sensor isn't working well, so we'll just disregard it and say take the 3 and average them and add the 4th in, and, you know, kind of guesstimate what your load is, as opposed to being completely shut down. Less susceptible to noise. If you digitize right, you know, close to the sensor, as soon as it's digital, it's very noise unsusceptible to noise, I should say. So that's an advantage if you digitize right at the sensor, as opposed to say at the end of a cable run. While analog speed, still get better, higher speed with analog. Typically, you can easily get 10 kilohertz bandwidth, whereas digital, that's somewhat of a challenge depending on the system. Analog's easy. People have used it for years. If you have analog inputs, just kick them on up. Get familiar with that. Less network bandwidth. Some of these things you talk about having a bunch of sensors all networked. Well, maybe your network guys wouldn't like you adding, you know, 100 sensors into their network. Might start to log things down. Again, compatible with DACs and PLCs. If people already have analog input channels, they may just plug right in. You may find that same DAC, though, or PLC runs out of input channels and you have to buy another expensive module, or if you just go digital, you might have a ability to add a lot more sensors without adding any extra hardware. So next slide, on to Ken.
Thank you, Keith. So as you know, Interface has a wide selection of wireless instruments, which includes Bluetooth as well. So we'll go over a little bit of the basics, just to make sure that you take these things into consideration before and during your use of these type of devices. Number one is safety, right? So we don't want to have any interruptions in the signal. Obviously, that would stop the readings, and if it's in a safety environment, let's say heavy lifting or something like that, we'd want to make sure that we see every reading and take every precaution we can. Make sure you're within the distance that that device can provide. We have devices that go from 500 to 800 meters and even longer using active repeaters. So keep that in mind. Clear line of sight. So you don't want metal objects and things like that right in the way to block that signal from getting where it needs to get. Battery life. So again, depending on what type of measurements and how many measurements you're taking, the battery may last longer or shorter. We also have options where you can hardwire in battery power, excuse me, so that you won't need a battery. If you need logging, we have those, of course, options. We're really good at system design. And then, of course, in regards to data rate, we've got 200 sample per second options up to 2,000 samples per second. And of course, there's trade-offs between here and there. So just keep that in mind. Next slide. The advantages of wireless, of course, cable-free. No wires, and of course, if you're in an environment that has forklifts and things like that running around and wires are sticking out, there's a chance they'll get severed, and you'll have some issues with that. Increased efficiency and cost savings. As you install more and more devices, you're just going to basically plug them in and pair them, and they'll communicate directly with, in this case, a base station. So you won't be adding wires and maintenance and things like that to go along with the additional devices. Flexibility in use and convenience just goes without saying. Expansion options, which like we say, you can add more and more modules. The only trade-off is that if they're all on the same channel, you may lose bandwidth or speed. So just keep that in mind. We can adapt this to any sensor that we have. We can put these onto moving parts as long as they're anchored firmly, and you can locate them in difficult areas to access. So things to keep in mind there. Next slide. When wireless isn't a good option. Obviously, if you got a metal building and you're trying to transmit from the inside of that building outside, you probably have some issues. We do have ways to work around things like that, such as antennas and repeaters. So we just have to be aware of it and maybe help survey the site. So but they can be worked around. Security concerns. There are ways to encrypt the information that's being sent out by our wireless devices, but still, it is in the air. So, today's hackers can figure out a lot of stuff. So just be careful. High data rate testing, mentioned that before. Obviously, the faster the data samples are going, the more the battery life is going to be used. So, and then the limitation is about 2,000 samples per second. Potential interference with other wireless signals. The good news is that this product comes with a spectrum analyzer, so you can analyze the amount of activity that's on any particular channel. And so you can change the channel to up to 16 channels if need be, but still other devices that come in and get installed, let's say after your installation, could interfere. And then long-running measurements, that battery life thing, which we mentioned in the previous slide. If that's the case, you can hardwire power into these units and still communicate the readings wirelessly. So we have options for that. Next slide. So we're going to talk a little bit about thinking about some solutions that you could do with wireless. We've got our WTS 1200 series. So that's an integrated wireless module there. The blue module on the side has 2 AAA batteries in it. The range is up to 600 meters. In this particular example, we'll have 4 of them located in a frame that's holding a boat. Next to it is our WTS Bx6 wireless telemetry dongle. This plugs into the side of your PC and can receive the signal that's being transmitted from the transmitter on the side of the 1200 series load cell. And then on the right there, we've got a picture of a PC with a mapping. We call it a mapping. And that's like a JPG picture of the of the boat, the actual application. And then you can see there's different windows that show the weights of each corner and the center of gravity. So what's neat about this is when you buy the WTS Bx6, you get the software, which is our WTS toolkit, and also our Log 100 software. So the Log 100 allows for, if you can see the very right side of the third graphic, you could see like a picture of the displayed value. So you could have up to 100 displays there looking at just displays. Or you could use the mapping option, which takes the JPG picture that you took, and you can configure this yourself. And then you can place little widgets on the screen that show the weights for each corner and the center of gravity. We have a great video series on our YouTube channel. So I would encourage you to go take a look at it, but it's so simple, it's fun to do too. Next slide. In this solution, we've got of course, the right side shows a gaming chair with pedals. The real life application would be a car test, automobile test. And in this case, we're using a WTS AM-1E wireless transmitter. So the previous slide, you saw an integrated wireless module. In this one, we would basically use the WTS AM-1E and connect it to the end of the cable for our BPL pedal load cell. The pedal load cell is connected to the brake pedal on the gaming chair. And so the WTS AM-1E can go up to 800 meters in distance. And since it's connected to this brake pedal load cell, as the person presses the brake onto their foot onto the brake, then the force that was applied will transmit to our WTS-BS-1-HS handheld display. So this one has a tare function, so you can clear the preload if there are any, and it displays the force that was applied, and then you can record it manually if you'd like. Another option is to use the WTS BS-6 we saw in the previous slide, and you could also log the data simultaneously, because the way the wireless works is as long as the signal from the wireless device is up in the air, any one of our base stations can read that as well. Next slide, please. In this application, it's a lifting crane, and it's got one of our WTS SHK-D wireless Crosby load shackle. So basically the crates that are lifted there their weight is being measured by the load shackle. And that load shackle has the blue module on the side, which is the wireless transmitter with the AAA batteries in it. And in this case, instead of using the WTS BS-6 wireless USB base station, we're going to use the WTS BS-3E. So that will give us a 600 meter range. And at the same time, the load shackle is transmitting the weight of those crates. The display that's shown there, the WTS LD2, is showing that weight for all to see. So that way the crane operator can know if they're entering into a danger zone and lifting too much that might tip the crane over. So, and again, we could be logging this onto a PC as well using the Log 100 software and logging and graphing it. Next slide. We also have Bluetooth options. So this here is our BTS-AM-1 module. And what's also there is our LBM compression load button. The application is mold ejection pin force. And so when a mold is created, they use pins to eject the mold from the product from the mold. And so sometimes customers want to know how much force it takes to push those molds out. And so in this case, you would use the your Android or your Apple device. We have an application, Interface BTS application that you would put on your phone. You create your app using the toolkit. We have a BTS toolkit that's an app. And then as the in this case, where the pin applies the pressure onto the compression load button load cell, then it would display the results of that force, ejection force, onto the phone or onto the pad device that you have. Next slide. Another Bluetooth application, just a couple of important notes. The Bluetooth works up to about 90 meters, and you can have up to 12 transmitter. So that's that first device there, our BTS-AM-1 connected and talking to that phone. In this application, what we've got is an ice machine with 4 shear beams and 4 of the BTS modules connected to it, and it's communicating to the phone. So the guy drives up in the parking lot, and his job is to make sure the ice machine is full, and he sees that wow, he's down 30 pounds of ice. So he's like I say, within the 90 meters, still in his car. Yep, I need to get out and add 3 10-pound bags, and he fills that ice machine up, and he hits the road. And if he goes to the next one and it's at the same level, he doesn't have to get out of his truck. Now, we do have other options, ways to use our WTS system, where we could actually put this information up on the cloud, and you could, you know, access it as well remotely to know what's going on. So you many options available in the wireless world. Next slide. So we have a lot of other devices. If you go to our website, you can see it. Like I said, quite an extensive offering of wireless solutions. And just to the right, we kind of feature a couple of ideas, parts that we have, active repeaters that can strengthen the signal and gateways and analog output receivers. And so what they can do is gather data from up to 100 acquisition modules, and that would be, you know, for the gateway in this case. You know, of course, their wireless configuration with ranges up to 800 meters, but with that active repeater, we can at least double that distance with a clear line of sight. The software is included when you get those base stations with it. And then, like I say, analog output is available. So if you have devices like PLCs that require that, you can have a wireless signal basically that transmitted from the sensor. The analog output module will receive that value and output the correct voltage or milliamp output that'll help operate that PLC. And of course, industrial and desktop versions of some of these products are available as well. Next slide. Keith, back to you.
Instrumentation. Hey, one thing I might point out on the wireless stuff too, it has a lot of built-in features to go to sleep and conserve battery life. So when they're not being used, they'll turn off and then they wake up and various things. So you get like a year's worth of battery on AA batteries when you use certain configurations. So just keep that in mind. So new instrumentation 9825 is a new one we're getting ready to release. It is pretty exciting. It's one of the first new panel meters we've offered in a while. We've had a lot of experience over the years with these types of instruments, and we do know that customers don't typically like to read the manual. So this one should be pretty easy. The intent is to user readable menu, so you can go to the menu system and figure out how to set it up and change things without having to, you know, read the manual, God forbid. But in any case, it has a lot of good features. It's a 6-digit bipolar, good nonlinearity. It's got analog output as standard. An analog output has 100 hertz bandwidth, has 1,000 samples per second, so it has peak valley monitoring, has digital output as standard. It's got some remote functionality. You can do a remote tear or peak reset via digital input. So a nice little meter panel mount. We also have various enclosures and things that these can be mounted into. Next slide, please. 9325, another new one. This one's probably not going to be coming out till the end of the year now, but it's a handheld display that has a nice multi-line display, very easily readable. So again, you can dig into the menu structure and navigate easily with pretty human readable prompts and things. It's relatively fast at 2,500 samples per second. It can log to PC software that's included. It has, TED's capability, all kinds of interesting features. It can store calibrations for multiple sensors. So we're excited about this one too. Released end of the year, probably. TQ, 9840 TQ. We've had the 9840 for a long time, single and dual channel versions. We've recently introduced a 4-channel version, which again, why would you want 4 channels? Well, this is a typically metrology instrument. So if you say calibrating a load cell and you have a triple bridge load cell, well, you need 1 load cell as your standard and then 3 channels for your 3 bridges. This is a new variant of the 9840. It's specifically for torque calibration. It's a single channel, has a higher sample rate, up to 1,000 samples per second, and it's got a first peak feature. So if you're calibrating, say, a click type torque wrench, once the torque wrench clicks, you don't want the second peak to obscure your first peak. So this will record the first peak and then ignore any peaks afterwards. It has some settings you can fine tune that to capture different types of clicking torque wrenches. Also, just has a regular old peak mode you can use with dial type torque wrenches. It's compatible with our gold standard software. And so it's a great addition to our metrology-based instrumentation and software. Next slide, please. This is new. It's the SIUSB4. It's a modular device. It's factory configurable, so it's not configurable in the field, but it is configurable with different types of channels. And there's up to 4 slots that can be filled with various different types of inputs, millivolt per volt sensors like load cells. It can take analog inputs like 4 to 20 or VDC, so that could come from like an LVDT or pressure sensors or whatnot. You can take encoder inputs and VDC, so you can do torque, angle, speed, power calculations. This is a USB interface to the PC, and it comes with software to view and graph and log the data. Next slide. Bx6, we're really excited about. This is not so new, but we're finding more and more new applications for it. It was originally kind of marketed as for use with our 6-axis sensors, and is great for that. Takes 6 channels of 6-axis sensor and does internal calculations and can actively scale its analog outputs per the calculations. Worked with our Blue DAC software. It's also just a great little DAC box. It's got 8 channels, plus it's got 2 extra channels for pulse encoders, and those are 3-channel, so AB plus index, and it can work with a bunch of different kinds of sensors. Voltage inputs, millivolts per volt, works with temperature sensors, type K thermocouples, BT 1000, temperature sensors. Can do bridge completion. So if you're using it with strain gauges or rosettes, it can actually work with those. Has internal bridge completion resistors. So again, if you're strain gauging something, you can wire it up appropriately and do the bridge completion in the box. 48,000 samples per second, synchronous on all channels. We can stack these together, so you can have 8, 16, 32 channels, however many channels you want. So pretty nice little box. We're finding more and more customers using it for just any old, instrumentation application versus specifically for 6-axis. Next slide, please. Just some features of this. It's high-speed synchronous sampling. So it's always running at 48,000 samples per second. You can turn that down as far as the data frequency being delivered to the PC, but it's always synchronous on all channels. Software is available, freely downloadable, no licensing fees, free updates, all that. We do have a new version of the software, which is Pro, and it's basically just add in like a plug-in to the existing software. It adds the ability to do some specific functions that most customers don't need, but if you need it, it's really cool. It's called math scripting. It allows you to add math channels to the software. Again, if you have more than one Bx8, they can be synchronized together, so they're all sampling synchronously and transmitting their data packets all in synchronous fashion. Fully LabVIEW compatible. BlueDAC software is written as a runtime license of LabVIEW, so the box is definitely compatible. We can provide VIs and programming examples and whatnot if somebody wants to use it with LabVIEW. Next slide, please. Again, 6-axis sensor is great. You can use it with 2 3-axis sensors. In either of those cases, you've got some extra channels left over for any of these described types of measurements. There's EtherCAT and CAN bus options. Always has a USB port, has a UART port too. We've done UART to Ethernet. We've connected Raspberry Pis to these things. So lots of fun options. And again, it's got DAC software, and the DAC software is expandable, so you can add more Bx8s. You can also add some other instruments into the mix, and they'll just add as channels. So next slide, please. Talked a little bit about math scripting. So basically, you can basically any kind of math you can think of, you can do as a channel, or then you can do math on other math channels. You can do all kinds of fancy things with this. A couple examples here. One is super simple. We have a 6-axis sensor. Customer wants to calculate the vector sum of the 3-axis forces and also of the 3 moments. And so you write a little script to do that. To the right is a little more complicated one. We're doing differentiation or differential and integration. So you imagine if you have a position sensor, you could find velocity and acceleration as different math channels from the position measurement. Next slide, please. So show you a little example. This is a 6-axis setup, and we can go in and add in a math channel. So math script, pick the vector sum here, add it in, and now we go in and add the 2 channels and connect. And now we go back to that previous display, and you see now we've got 2 extra channels. We can rename those, but right now it's the vector sum of the forces and the torque. So simple as that. Next slide, please. BSC4, this is kind of the BX8's little brother. It's 4 channels. It can work with millivolts per volt, strain gauge, or 1.5 bridge completion. So if you're doing strain gauge work, it plugs in real nicely to our 3-axis sensors. Has an extra channel, and there's 2 versions. One is a BSC4A, which is only analog output. So it's basically a 3-channel or 4-channel analog output. So again, works great with a 3-axis sensor if you're going to go to a data acquisition system or something that requires analog inputs. The BSC4D is a digital version, and instead of analog outputs, it has a USB connection to the PC. Again, fully LabVIEW compatible. We can provide programming examples if somebody wanted to write their own software to work with it, DLLs and whatnot. Next slide, please. So advantages, these are nice and compact. If you had, say, 3 or 4 amps and you stack them together, they'd be quite a bit larger package than this. So it's nice and compact. The digital version, the USB version, has digital inputs and outputs. You can set thresholds and set points, and they'll actually trip internally. So you can set them, say, with the software, but the digital output will trip, say, if you exceed a certain threshold, and that could go right to a controller or something. Doesn't have to be processed through the PC. You can also command zeros and tears and things externally with these. Next slide, please. Use cases, kind of went over this, but 3-axis sensors, or you can 3-axis plus an additional sensor. There's versions of these with a 37-pin connector on it, and those connect nicely to our 3-axis sensors. We also have versions that have 4 M12 connectors, so if you want to input separate sensors. You can also use multiple digital versions of these together. They can be synchronized via their I/O port, and so they can, again, sample synchronously, which can be useful. Next slide, please. This is new, the Bx6 Bluetooth high-speed data logger. It's a little module, as you can see, not too much bigger than a paperclip. It's got a micro SD card, has Bluetooth connectivity to the PC. It's compatible with the BlueDAC software. It's 6 channels plus 1 encoder channel. The channels can be either strain gauge, and that could be full Wheatstone bridge like a load cell, or it can be actual strain gauges applied, and that can either be half or full bridges or quarter bridges, and has internal completion resistors. It's got voltage inputs too, so any of those channels can be set, say for a voltage input, you had to censor the voltage output. 16-bit resolution. It can log to the SD card and broadcast data over Bluetooth simultaneously. So if you got a wireless connection that falls over for some reason, you can still grab the data off the SD card later. Next slide. Oh, it's relatively fast, 3,000 samples per second on a single channel. Compatible with our 6-axis sensor, so it'll do the 6-axis math internally and broadcast data or log data as the newtons and newton meters. Got a built-in battery charger, so it can be hooked up with systems that have rechargeable lithium-ion batteries, and an antenna, like you see the little box here, where this would be a little data logger module. We can package this in all kinds of different ways, depending on what the requirement is. Next slide, please. This is a new version of it that's coming out in a few months. Where basically take that and then break everything out onto screw terminals and mount a little hinged box. So this is a little bigger, obviously, but if somebody doesn't have a space constraint, this can have a long battery life and lots of ease of use features, make it easy for somebody to use. Again, this is completely LabVIEW compatible, and somebody could program their own software to work with it as well. Next channel, please. Back to Ken.
Thank you, Keith. I guess we've got software.
All right, we can talk about this. So we talked about Bx6 software, and this just showing what it looks like a little bit more. It's got graphing and logging. It saves the data, and it has a file monitor you can use to open data and view it afterwards. You can find peaks and valleys easily. You can export to Excel if you want. Quite nice. But the nice thing about this kind of software is completely set up for using it with sensors like we sell and we use. So it's not like, oh, customers go in and program it or figure it out, right? It's basically good to go as soon as you open the box. Next slide, please. Software that comes with the WTS and the Bluetooth is a little different. There's a toolkit that's used for configuration, scaling, calibration, all that good stuff. And then the kind of the user interface software is this log 100, which Ken talked about. This is a representation where a customer was doing an airplane weighing, and they have jack points all over the aircraft, and they wanted to have a readout or a display that showed all the values live. And actually here they turn colors, so they're green, orange, and red, and they start to flash if you start to exceed certain points. So super handy. You can have any number of mapping screens too. So you could have, say, different airplanes. You can pull those up, or you could have, say, a zoomed in view of just the wing. So like the next screen could be just the wing if you're going to jack up one wing or something. You want to have a bigger view of just one section. So quite fun to play with, actually. Again, if you want to go to, say, instead of WTS, Bluetooth, we got the ability to have something on a cell phone or a tablet if you want to walk around and, say, pull data from something in the factory. NFS3 software is the one that's compatible with our INF-USB or the SIUSB4, which we showed. A little bit different, but it shows graphing and logging and displays. It has a nice pass-fail feature too, where if you, say, test some conditions, it'll give you a smiley face. If it passes, it'll automatically log that data as a pass and then let you move on to the next test. Next slide, please. T25 is a variant on that software we just showed, but it's specifically for use with USB output torque sensors. It can also be used with torque sensors that have RS-45 output option, and it shows torque, RPM, angle, and can calculate power as well. Next slide. So now we're over to Ken.
Hello, yeah, so these are trends in test data management, and Interface has product that can pretty much cover all these categories. Of course, Keith already mentioned the math scripting, which is really a neat feature of our Bx6 software. And then, of course, real-time data manipulation versus post-processing, so you can, while you're live reading or displaying the data, you can also record that and then go back and do some analysis on it to see, are there any patterns or what did we learn from this particular test? Remote access through equipment like our WTS, for instance, customer can access through their network and look at any device that's running particular tests, etc. Transmission to the cloud, we have that as well. So you transmit from any wireless device or other devices as well, and put that data up in the cloud so somebody can grab it and look at it and analyze it. Alerts, notifications, automated reports, advanced triggering and logging. All these are features of different products that we do have. Bx6 integrated in a factory. Keith's going to have a nice application coming up here real soon that shows how Bx6 can be integrated into a complex application and networked. So that's going to be a nice one for you to see. And then, of course, as mentioned throughout this presentation, just mixed and expanding communication protocols. Interfaces strategy is not to dictate to our customers what protocol they need to use. Whatever works best in your factory, you choose, and we'll be able to make our equipment work with your setup. So next slide. So building advanced testing systems, of course, we're very strong in the custom solutions here. It's been a very successful and growing business for us. It includes custom enclosures, the way we can package things up. We've done some encapsulation, which when enclosures don't exist for what customers need, we've created them. Any kind of connectors. Sometimes, if you look at Interface's offerings, you may see certain types of connectors. We've done other types that are more complicated. Plug and play. As Keith mentioned, we have all the TEDS, 33, 40, and 41 options, but plug and play can also mean you buy it from us, we set it up, we scale it, we put it in a custom enclosure, whatever you need, and then you get it, you just plug it into your system and start working with it. Included in that can be custom programming. So, we've done this for customers before. We sit down, we talk about what their application is. Is it something we can do with our standard product? If not, then we can get a custom program made that'll do what you need to do. So integration with other equipment, DIO switches, sensors. You'll see an application note coming soon that'll show you a little bit more about that. And then, remote access to data, which we mentioned before. And then lastly, mobile testing labs. So things that may be battery powered and have load cells in them and that kind of stuff. We can put that all together for you and make life easy for you back at your plant. Next slide.
Applications and use cases. This is an interesting one. A customer was looking to measure and study cutting tool forces and establish whether a hexapod-based measurement system would be accurate, and they were able to compare those results with 6-axis sensors that were mounted as well. So this system consists of 2 Bx6s for use with the 6-axis sensors, another 3 Bx6s that were used for load cells, and then a rack to mount the Bx6s. And these are EtherCAT Bx6s, also plugged in via USB for easy configuration using BlueDAC. So the sensors were 2 6-axis force and torque sensors. There were 24 single-axis force sensors. There are 6 encoders. BlueDAC software is used for analysis, some math scripting channels to calculate loads and forces and torques in 6-axis using the hexapod arrangement and comparing that to the 6-axis sensors. EtherCAT connections back to the PC running control software to control the system, and it's a high-speed synchronous sampling on all of the channels. Next slide. This is a little zoomed in picture of the rack-mounted Bx6s. Say there are 6 main struts with electromechanical actuators. There's load cell on each end. Again, just to compare and see which loads corresponded best under, once you do the calculations, if it made sense to have load cells on both sides or one or the other was better. So pretty interesting, just sort of an example of lots of sensors being integrated into a system with a lot of force measurement. Could also be, other types of sensors as well. Next slide, please.
So this one is application basically showing, multiple sensors used in a solar tracker application. Basically, the goal here was to measure temperature, wind speed, torque, position, angle, and force. And so we had temperature monitoring, encoders, torque transducers, load cells, 3-axis mounted on the feet of the solar panels, and they all were equipped with a WTS AM1 transmitter, then transmitted to a WTSSS gateway, and that will transmit the data up to the cloud. So any of these activities that are going on in the application will be transmitted up there for viewing and recording, logging and graphing. So a lot going on there, but all handled through the wireless system. Next slide.
This is an example using SIUSB4. Have a torque transducer with a voltage output and an encoder output hooked up to the SIUSB, also a load washer, millivolt per volt sensor. It's measuring clamping force as the screw is turned in, clamps down on the load cell. Can actually monitor, how many rotations, what the torque ramp up looks like, and what the clamping force looks like. You can compare those. If it's within a certain window, that would be considered a good test. If this is, say, on a production line, you could actually have a pass fail. The operator just, turns the screw and gets a smiley face if it's good to go or not. All can be used in the R&D lab, obviously, as well. Next slide. Ken can talk about this one.
Yeah, this is application, another application for a wireless product. This is kind of a self-enclosed portable unit. We've got a Pelican case with 5 each of our 9812 wireless displays, and we'll use 1200 series wireless load cells. This is designed to travel with the airplane. They can do, maintenance anywhere this airplane goes. What's featured is we've got battery power that can power these units for up to 20 hours. The charging can be done with 110 power, 28 volt power, or 220 volt power. And all the information can be transmitted to our, to the PC using the USB base stations. And as Keith showed in a previous slide, you could use the mapping with alarms so that when you're doing that maintenance, you'll know if you're putting too much stress on any part of the plane, and you can stop doing it so you don't damage the plane. So this is stuff that we can definitely put together for you. Next slide.
Frequently asked questions.
So Keith, what software works best for test and measurement instrumentation?
Good question. It really depends, right? We've got some really nice software that's plug and play, basically set up for sensors and can start taking measurements right away. If you have a much more complex system, maybe better to, use something like LabVIEW or Gantner or, DeweySoft or, High Techniques. There's all kinds of instrumentation out there in the world. And maybe you've got that software, so maybe you want to use some of our hardware and you want to interface with it. It's LabVIEW. We definitely have VIs and drivers and things. So it just depends, I guess, is the answer. But if plug and play, you want something that works right out of the box, don't have, comes free with the hardware, ours is always a good choice.
Does the out of the box software do math equations?
Some does, some doesn't. So it's important to discuss that and that can be added to some software. Some of it's inherent, some of it absolutely cannot do it. Of course, you can always do it in post analysis, but if you want it live, we need to know that up front and choose the right software.
What is some of the criteria I should use when I'm comparing similar instruments?
Well, as Ken mentioned with the selection guide, you really have to kind of understand what you're trying to do, how many channels, what existing hardware you're trying to interface with, what sensors. A lot of times, you're talking to us about load cells, but what other sensors do you have? A lot of these boxes have extra input channels, so you can actually add sensors that you may already have. So it's good to look at the whole system and make a decision, that way instead of looking at it piece by piece.
Why Bluetooth versus wireless?
Well, Bluetooth is nice if you have a cell phone or a tablet or something you want to just walk by or walk up to something and pull some data from it. It's not so great like in a factory if you're trying to have multiple sensors and have any kind of complicated system. So it just depends. Bluetooth is easy and convenient, not necessarily suitable for industrial or real test and measurement use. So it really just depends.
Are digital outputs more accurate than analog?
They certainly can be, in that you don't have any signal disruption, or you typically wouldn't have any after it's digitized. So you can get a nice, accurate, high resolution digital signal, from there on, it's good all the way down through the chain.
Where can I find information on drivers, files, and toolkits?
Well, we have all of this readily available. It's not always super easy to find on the website, so obviously your application engineer is a great resource. We are working on having everything up in easier to find places on our website, but right now the individual product pages have information, have drivers and things, but if something you can't find, definitely consult with your AE and we'll get it to you.
Can I turn my load cell into a wireless measurement device?
Absolutely. We've got load cells that have integrated wireless, but it's always a possibility to add an external wireless module, and they can be quite small or it can be bigger with D-cell batteries in them. So we have a number of different options for externally mounted wireless.
Are drawings available for this instrumentation?
Absolutely. Again, many of it is available for download from the product page. If it's not, or there's some special configuration, or particularly enclosures, if you want, something, we can make drawings with the exact feed throughs and connector layouts and all that stuff. So absolutely available, maybe downloadable. If not, per request, we can create it quickly.
How often should I upgrade instrumentation?
Weekly. Well, good question. It depends. Sometimes you find it's kind of getting it's kind of futile to work with older equipment that's really becoming hard. There's a number of systems in the world that maybe are stuck on like Windows 7 still, and as things become less compatible, it makes a lot of sense to upgrade to, systems that are compatible with, Windows going forward. So it really just depends. Systems themselves typically maintain their accuracy and their usability for many, many years. So there's no reason to necessarily to upgrade unless, something is driving it, but just to do it because it's old, not necessarily a good reason.
Can you help with a cloud-based system?
Yes, we can. Ken showed a nice example of one, and lots of details on what a customer may want, but we definitely can help with that.
Excellent. Next slide. Do's and don'ts. Obviously, there's a lot of these, so do consider instrumentation early for project requirements. Know where and how you will extract data. Consider your communication protocol requirements. Don't wait on decisions for that instrumentation. Don't assume electronics requirements are standard, and especially these days, good to get your orders in early because of component availability. We do have Bx6s. Know what you want to measure. Know how data needs to be retrieved, logged, and stored. Bring electrical experts into requirements discussions early, and explore possibilities and ask for help. Next slide. Choosing interface instrumentation. Well, I'm going to pick a few of these, but there's many, many reasons to pick us. One is a single point of contact for the measurement device and instrumentation. Another one is we're really great at partnering with our customers to design and build complete systems for you. We can go across all sensors. You know, we have a lot of experience not only with load cells and torque transducers, but other types of sensors, so we can solve complex problems. And then, as you've seen, we have software available and we can do customized software. Next slide. This is just kind of a graphic that shows some of the things that we're known for.
Yeah, so we have a couple of questions that came in during the presentation now. So if you have questions, be sure to use the chat feature. First of all, Kevin wants to know, does the 9825 have remote excitation sensing?
Yes, it does.
Good answer. Second, he wanted to know, does the 9840 TQ panel mount size, is it as small as the 9840?
It's about twice as big, or maybe even as big as 494. So quite big, which is nice because it's got nice big displays on it, but it is quite a bit larger.
I think it's a 19-inch rack mount or something. So I
Okay.
think that's what it is.
Very good. If you have questions, use the chat feature. I know we covered a lot in a very short period of time, but we will have this information available on the website. We'll send you a link to the presentation, and we'll also be putting it on the YouTube channel where we have all of our ForceLeaders events. But as you can see, instrumentation can be quite complex, but then we also have some very simple solutions as well. So our application experts are really here to help. And all of our representatives and distributors throughout our global sales network have that background and expertise as well to assist you. So be sure to let us know. Any other questions that come to mind as you've gone through this presentation a few times here, Ken and Keith, that you think would be helpful when people are getting started with assessing their instrumentation requirements? You know, we've talked about this selection guide. What other tips could you provide?
Well, I think that, obviously call interface and talk to the application engineers. We're one of the, I'll say, few companies out there where you can actually call and somebody will pick up a phone, or you can email and somebody will answer your email and they'll give you the detail. You know, okay, what kind of things you're trying to do. They can give you a bunch of options, which is great. We have so many. And then you can decide for yourself, okay, I think this solution kind of fits us best. So you'll have the choice, but you get lots of options.
Yeah, and on the website, there are multiple places that you can find this information. We have 2 sections under product, under instrumentation and digital instrumentation. We also have the files for 2 toolkits under the support section of the website. And then as noted, we have design files available and so forth, but it's always a good place to get started with an application engineer. Jose would like to know, are there any demos for the software? And before you answer that, I will say on the YouTube channel and also on our website, if you go to the support section, we also have a training and education area. And we've got some really cool Log 100 demos, and we continue to add new videos almost every week now. But
yeah, so demos, again, as Jamie mentioned, videos, we have some of those, and we also are really happy to do Teams meeting or Zoom or whatever, and actually fire up software and walk you right through it and show you whatever you want to see live on screen. We also have local distributors and representatives who are happy to do on-site demos. We'll have to, obviously ship hardware and everything, so that's not as convenient, but certainly anytime we can schedule a Teams meeting and, do it live right there.
yep, that math script was recorded in Teams, so we're here to help. All right. Well, we're coming to the close. It's been a full hour, a lot of information shared. If you have additional questions, be sure to ping us. We're here to help. I would like to thank everybody for participating today. Keith, Ken, always a wealth of information. And thanks for everyone for joining us today. Watch for the email with the link and have a great day.
Thanks,
Thanks,
Amy. Thank you, everybody.
Thanks, everyone.